out, you can always go check out the Canvas page for that date. So if you're confused about your notes, go to the Canvas page and you can find my video, and hopefully the explanation will help jog your memory. So really, really important that you write your date on all of your notes. All right. So we're starting with our goal today. We're going to identify discrete and continuous data sets, or data sets, depending on how you like to say it. And then we're going to find central measures of tendency. I think it's a pretty low-key day for us. We should be able to get through it pretty quickly. First thing, definition of univariate data. It's just a fancy word. It really just means single variable data. Okay, so we're starting with statistics this year, FYI. Okay, so univariate data is. I just want to make sure I get the definition similar to what your book has written down. So I'm going to find that in your book. Okay, yeah, so univariate data, easiest way to say it is it's data that has one variable. All right, that's it. And so chapter 3 in our textbook, this is our first one. It's called Descriptive Statistics. It's going to be all about single variable data. And then we're going to move on to something called multivariable data next. Okay, so this one will take about 2 weeks, and then we'll move on to multivariable data after that. Two types of single variable data. There's qualitative and quantitative. Qualitative means quality, all right? So you're taking quality data. Okay, another way to think about qualitative is it's not given numerically, okay? Versus the other data is quantitative, and that is given numerically. Sorry, I'm writing kind of fast. I'll slow down. Numerical data. That's what quantitative is. Okay, so qualitative is like really in-depth research. I focused on this one student for a long time. I wanted to see how this student did over the course of a school year. So I followed them around and took really in-depth notes on how the student interacted with online learning. Okay, quantitative is more like I used 30 students, so I'm putting a number on it, okay? 30 students, that's the difference. And then we have discrete data versus continuous data. You've probably heard those terms before in AGS, like way back in the day, all right? And those are the two types of quantitative data we're gonna be focusing on, all right? And the big difference is discrete can be counted, and continuous can be measured. So some examples of discrete data, things that you can count. It's like number of students, apples picked at an orchard, something like that. Okay, those are just some examples of discrete data. Things that can be measured, okay? You'd say like the weight of the apples at the orchard. You go to the Fruit Loop in Central Oregon, in Hood River. You pick apples, they charge you by the weight, so you're gonna measure how much they weigh. Okay, so that's the difference between discrete data and continuous data. All right. Other things that could be measured, height and age of people. That's continuous data because you're measuring how old somebody is, you're measuring how tall somebody is. You don't count how old somebody is, okay? Okay, so that gives you a little hint for our first example too. So first example says that we're looking at the age of students in a football club, And then I have this long list of ages of students. Okay, state whether this data is discrete or continuous. All right, so first, ages, is that going to be discrete or continuous data?
Continuous.
Done. Easy. That's it. Okay, told you today's going to be an easy day. Continuous data. All right, so we have to be able to identify that first. Construct a grouped frequency table. This one's kind of weird because your textbook just starts using these weird terms. It does this a lot. So if you're a person that likes to read, you're a visual person, when you get your textbook, you can hopefully read through it and it makes sense to you. But otherwise, I'll just have to explain things as we're going through. So I'll create a table here. A frequency table is going to look like this. Need some space. And basically what we're going to do is we're going to create two columns. One that's age and one that is frequency. Okay. I'm going to zoom in on this just a little bit. All right. And I'm going to try and keep my data set in the picture as well, I guess. Woo, there we go. All right, so what happens for age then is, let's see, we'll just make different columns. We'll start with the youngest. So it looks like the youngest kids are 10. And it says let X represent your age. So the big thing is, though, you're not just 10 years old, right? You're 10 and 46 days, or you're 10 and 362 days, right? Not quite there. Okay. So what we need to do then is we need to say, well, you're starting at 10 and you're going to whatever age you are until you're 1 day shy of your 11th birthday. That's how you're going to put your that's how you're going to put your age on there. So you're not just, yeah. So like in our class, for example, there's a lot of 17-year-olds because you're seniors in our class right now. All right. But you're not all the same exact age of 17. You're born on different days. So what I'm saying here is I'm going to capture all of the 10-year-olds on this frequency table. And then all I have to do is count my data and say how many 10-year-olds there are. So let's count it together. And I'll just mark them off as I'm going. I'm going to get a little highlighter here and mark them off as I go. 1, 2, 3, 4, 5, 6, 7. So it looks like we have 7 that fall into the age 10 category. That's what our frequency would be. Okay. And then you guys go ahead and do that for every age group that we have. So we would do our 11-year-olds. So notice that our age is less than or equal to 11, but strictly less than 12 because we don't want to count any 12-year-olds in there. Anyone that might be on their 12th birthday. Okay, and then same thing with the 11-year-olds. Just count it up. 4, 5, 6, 7, 8, 9. So I got 9 11-year-olds. Why don't you guys go ahead and fill out the rest of this table. Okay, go ahead and count your 12-year-olds, 13-year-olds. I think we go all the way up to 16. Okay.
How do we label it for 16?
I would say 16 is less than or equal to X is less than 17. There are no 17-year-olds on the table, so as long as we're less than that, we're fine. I don't think I made enough columns. All right, so we're doing okay. I see a couple people still look like they're working on it. All right, so Ruby, what did you get for 12 to 13-year-olds? How many did you find?
The frequency?
Yes.
7.
Perfect, thank you. All right. Let's see. And Chloe, what did you have for 13 to 14-year-olds?
I got 3.
3, okay, thank you. And then Mason, what did you get for 14 to 15-year-olds in this one?
I got 4.
4, perfect. If anyone has any discrepancies, let me know. But I think we're looking good so far. Olivia, 15 to 16-year-olds?
I got 5.
5, perfect. And then last one, 16 to 17-year-olds. Vivian, what did we have for 16 to 17-year-olds?
I got 5.
5, perfect. Okay, I think that matches up. Okay, good. So that's a frequency table. So that's the whole idea. So again, it's really weird because the wording's weird, but that's all this is asking you to do on this type of problem. Construct a grouped frequency table. All right. That's the end of page 1 of our notes. Measures of central tendency. We've seen this before. Mean, median, and mode. All right, that's the second half of our lesson today. Should go pretty quick. So what's they all measure trying to find the center of your data set, okay? So measures of central tendency means finding the center of your data set. I'm going to write that down. Okay. So mean, median, mode. Do you guys remember which one's which or how to find each one? Let's start with, if anybody wants to jump in and tell me one of them, you can pick any one of the 3. How do you find that center, if you remember?
Median is like if you put all the data from like smallest to largest and then like you go to the very center number.
Exactly. Very good. So you sort your data from smallest to largest. So you have to reorganize your data. And then you literally count to the center number. And if you have an odd data set, so like if you have 11 participants, then it's the middle number. You count in 1, 2, 3, 4, 5, 6 from the left side, count in 1, 2, 3, 4, 5, 6 from the right side, you're going to be in that center number. If you have an even number, you're going to get halfway between 2 numbers, so then you have to take the mean of those 2 numbers. So that's kind of my hint for mean. How do you guys find the mean?
It's pretty much just finding the average. You add all your data points together and divide it by how many data points you've got.
Exactly. Add all data points together. And divide by the total number. The number of data points. Sorry, I did not give myself a lot of space here, so that's why I chose a different color. And then the last one, the mode. Finding the center using the mode. And you remember what that one is?
That's the number that shows up the most often.
Exactly, the highest frequency number, okay? And so when we're looking at our data set from example 1, What's the mode going to be in that one? Which one showed up the most? Which one had the highest frequency?
11.
Yeah, exactly. Age 11, exactly. So if you're somewhere in the 11 age range, because there were 9 people that were 11 years old. Okay, so that's how the mode works, which is kind of a weird representation of center, right? Because you're saying, what's the average age of people? Well, you could say, well, it's 11 because the most people were 11 years old. Okay, mean's gonna add all those up and then divide. It's kind of weird. Okay. Let's see. So we'll look at one more example here. The grades in a history test for 14 students were as follows. So 58, 67, 66, 58. Someone got a 35. I feel bad for that person. See, the trick is when you're taking a history test and you don't know anything, don't sit next to the guy that got a 58. You got to copy off somebody else, guys. Come on. Be smarter than that. Now, these are bad history test scores. Okay, so go ahead and find the mean, median, mode for these. We'll do the mean together. We're just going to, I guess the first thing I'm going to do is actually I'm going to resort my data because I think that's going to be the easiest to do. So I'm just going to, let's see. Resort data. I'm just going to write them from lowest to highest first. 35, 49, nope, 47 goes first. 49, and then in the 50s I got 1, 2, 3 58s. When I go to the 60s, 66, 67, 69. And I got a 76, 79. Put commas in here. Space it out too much because I'm running out of room. And then I have an 83, 88, 91. And just as I'm resorting my data, because there's so much of it, I'm just crossing them out as I go, and I'm working in the tens column. So I worked in the, so just a little example of how to break it down easily. Okay. So there are 14 students, and because it's an even number, I know my mean's gonna fall halfway between two, or my median's gonna fall halfway between two numbers. So I'll have to take the mean of those two numbers once I get there, which is kind of weird. 4, 5, 6, 7. So the median's halfway between 66 and 67. So my median's going to be 66.5. Okay. Go ahead and find your mean and your mode. I'm sure you guys have been working on it already. So add all the numbers together, divide by 14. Okay.
66.
Yeah, it comes out to 66. Perfect. I like that. Nice clean number. All right, and then the mode, which one occurred the most frequently? Also really 58. Also really easy to see when we resort the data. You can see 3 58s in a row there. Okay, so that's our mean, median, mode. Oof, I did not leave a lot of space on the next problem. I'm sorry about that. But it says when a 15th student took the test, the mean became 66.2. Calculate the grade for the 15th student. So how are we going to find the score of the 15th student if we know the mean? Okay. So what we want to do to find the grade of the 15th student is we want to work backwards. So think about, we know the mean is 66.2. So we can actually set up an equation for ourselves. 66.2 equals, we'll just put whatever the score is of the student. We'll say x over 15, because there are 15 students now. Actually, that's not the score of one student, though. What's that x representing right now? That's not the score of one student. That's the score of?
The average.
It's the score of all of my students, yeah. So 66.2 is the average, but the x is going to be score of all of my students. So if I did 66.2 times 15, I get 993. Okay. And what was the total of my scores before on the previous problem on part A?
924.
924. Perfect. So I can do 993 minus 924. And I'm going to write down here real quick. Or sum of part A, I should say. And then we can find out what our answer is from that. So that was the sum of 14 scores. And we end up getting 69. So that's how we find the last score there, 15th student. Okay. So whenever you get a question like that, if you're planning on taking the IB exam loves to ask questions that make you kind of work backwards. So you traditionally know how the formula works the straight up way. IB exam loves to get you to think a little outside the box. Like, how do I get back to the start? Okay, from all this information. So that's a really good example of a classic IB exam type question for like a mean, median, mode. That's how you make a mean question difficult. Okay. Or assuming that you know how to calculate the mean already. Okay. Okay, last example here. Mindy opened some bags of candy and counts how many pieces are in each bag. So her results on a frequency table. Okay, so find the number of candies in each bag. Okay. So which center do we want to use to find the number of candies in each bag? Is the mode going to make sense? Is the mean going to make sense? I know it just says the number of candies. I feel like it should say average number there. We'll say average number. I'm just taking this out of your textbook. Okay, so what we're going to want to do is we're going to want to find the mean of the candies here. So if I were to list this data set out, there are 2 23s, 3 24s, 9 25s, 1 2 3 4 5, 6 7 8 9, 5 26s. Is there an easier way to write this out than writing it out all longhand? There's probably an easier way to do this mean problem, right? If we're looking for the mean.
By putting the numbers in brackets and multiplying.
Exactly. So thinking about the frequency table is there for a reason, because it's going to be easier to say 23 times 2 plus 24 times 3 plus 25 times 9 plus 26 times 5 plus 27 times 1. That's going to save me a lot of time writing it. And then the frequency, I just had to add that up. 2 plus 3 plus 9 plus 5 plus 1. All right, I'm going to do that in a different color, actually. So I'm going to highlight that in blue. There's our frequency. And that's what's going on down here at the bottom. So you know where those numbers are coming from. And then we can go ahead and find our mean. And in this case, the mean is, I think it comes out to probably 25 because there's so many dang 25s there. It'll probably give us a little fraction, but because we're talking about candy here, you're not going to have fractions of candy. So the answer should just be 25. All right. Wow, and just like that, first day's in the books. So